And our captions are showing, so that okay. Now let's make sure this is up. 4.3. Okay, so you made some pretty good progress, it looks like. Number. Okay, so starting with 13.
Yep.
58% of American children are read to every day by someone at home. Okay. Suppose 5 children are randomly selected. What is the probability that at least one is read to every day by someone at home? Okay. So, one thing I do want to mention for your sake and for the sake of people who will be watching this later is when you get further into the chapter, when we get into the next couple of sections, there'll be more than one way to solve some of these problems. And even now, you might find a couple of different ways to solve them. You're welcome to use any method that she's actually shown in the slides. So after, for example, number 14, once you get into 4.4 and 4.5, you'll see that there are more ways than just one to do this. You're welcome to use any way that makes sense to you as long as you could show it properly, mathematically. 58% of American children are read to every day by someone at home. Okay, so we're choosing 5 of those kids, all right? And it doesn't say that they're from the same household. It just says we're choosing 5. So when you're doing at least, one of the most common ways to work with at least is to use the complement when you have at least one. So that one of the ways to approach this problem would be to do this. We would say, let me hold on, because I'm not okay. So we have, this is 13. So we've got the probability of being read to at home is 58%, right? And so now we also want the complement of this event, which means that I'm not read to at home, because either I am or I'm not, right? So the probability of not being read to at home is the complement of that event, which is 1 minus 0.58. So this is going to end up being 0.42, because this is going to equal 1 minus 0.58, which is 0.42. Now, if you choose 5 at random, right? So we're choosing 5, choose 5 at random. And you want to find the probability that at least one is, let's see, at least one is read to every day, okay? So you're picking at least one that's read to. So the only thing you're not picking here is that they're not being read to. So at least one is read to every day. So if we use the complement of that, because otherwise we're going to have a bunch of fractions. We're going to have the probability of at least one read to every day is going to equal 1 minus the probability of none being read to every day, which is why I needed the complement up there of 42%. So now I can write this as I can write this as 1 minus. Now, none of them means that all 5 of them are not being read to. And if they're not being read to, we know the complement was 42%, and there are 5 of those. So we're going to write and say that there's 5 of these. And when you put this in the calculator, it should calculate this portion first. So let's look at that and see what we've got. So we're going to have a new share. Yes, we are. Okay, so we have 1 minus. I was doing a different problem earlier. 1 minus. This is 0.42 to the 5th power. And there we go, 0.9869. Let's take a look at, that was 13. Let's see if I'm, which matches what the answer key says. Any questions about that one?
No.
No? Okay. 14. If 4 cards are drawn from a deck of 52 and not replaced, find the probability of getting at least 1 club. Okay. This, we can approach this in a similar way. There's a couple of ways that I suggested. One of the ways that I suggested we do this, and there's about 2 ways that we could do this that would be possible with the knowledge that you currently have. So on number, let me write the answer here to this one first. This is 0.9869. So, and that's equal to 98.69%. Okay, so now number 14. Here we're choosing 4 cards and we're choosing 4 clubs, right? So we're choosing 4 this says you choose clubs, I think it was. At least 1 club. Okay, 4 cards are drawn from a deck of 52 and not replaced. At least 1 club. So here you have four cards at random without replacement. And we want find probability of drawing at least 1 club. Now, we have to remember some things about the cards. So here, do you remember how many clubs are in the deck altogether?
52.
There's 52 cards in the deck. That's right. There's 52 cards total. How many are clubs?
10, 13.
13 clubs, right. So we can employ the same kind of strategy here. We can say, well, we can employ the same kind of strategy that we did on the previous one. So we can say the probability of at least one club would be 1 minus the probability of no clubs. But now here's the trick with this. This still works. This idea still works, except the probability doesn't stay the same in this case, because once you remove those cards, there's a different number of cards every time. So what you can say here is you could write 1 minus. Now, I'm going to put some parentheses up here. Now, if there's 13 clubs, then that means there's a total of 52 minus 13, which is 39 cards, right? That are not clubs. Okay, and that's what we're going to be drawing from, because we want 1 minus the probability that none are clubs. So the first time we draw, we're going to have 39 out of 52, right? And then we're not replacing it. So now, whatever card that was, it wasn't a club, right? But it also wasn't the card that we already drew. So now there's only 51 cards left, and there's 38 of them that are not clubs. So this is 38 out of 51, right? Because I'm doing, if there's at least one club, then I don't want these to be the probability of no clubs. So 39 of 52, 38 of 51, right? Then 37 of 50, and 36 that's one way of doing it. Okay, the other way to think of this is to say, all right, well, here's another way to think of the same question. You want at least one club, so you want to have one club and 3 other cards, or 2 clubs and 2 other cards, or 3 clubs and 1 other card, or 4 clubs and no other cards. But that would be a lot more fractions, right? So what I'm doing here is I'm using the complement there with no clubs to get myself into that situation. So now there's a little bit more stuff to enter. We can, so it's 1 minus, and then we have 39 of 52.
We divide, we calculate all that?
Uh-huh.
Okay.
Yeah, I mean, you can, this fraction, this 39 of 52, you can reduce. The other fractions don't reduce, but this one should. 39 of 52 reduces. But I just wanted to show you that, because this is the first problem that you and I have done that have to do with being without replacement, I think. I think we had one more last week at some point, but it's been a minute since we've done it. 50 and 36, 49. So. And I think I gave you the, I'm gonna see if this is the same thing that she, because I remember us doing it. Is it this answer? Let me see if hold on, because I think, give me a minute, because I'm having, I know hold on, yes, I realize that, okay. Let me go to my email, because I also have because I remember it came from the other 4.3 solutions. Yeah, here we go. No. Okay, where is it? She said that if you end up having, because I did ask her this, if you end up having ones that don't come out on the calculator, and I think this was one of those ones that didn't, in terms of it didn't want to convert it to a fraction, as I recall, that you didn't have to do that. Let me see if this,
Because
yeah,
I
so
calculated everything and I got a different answer.
okay, let me show you what what did you get?
0.7080968858.
Okay, it should be, hold on, let me put it up so that, and then we'll redo it, because I actually did get the same thing that but let me put it on the screen. Here is the sample space. Let me share. Hold on. She gave you here, whoops, this is not the one. This is the one. She gave you a picture of the sample space, right? So 1 minus, again, there's 39 cards that aren't clubbed. Okay. Then there's 38, 37, and 36, right? So go ahead and
Yeah, I've been calculating it and nothing happened.
it didn't, okay, let me do it again, and let me see what's because I think I put it up there. So let me stop sharing this and go back to, let me put it on the screen. So here, make sure that you have, okay. So 1, let me bring this up this way. Are you seeing my calculator screen? You should be.
Yes.
1 minus, be sure you're using the minus sign, not the toggle down here. And then you're gonna go open parenthesis 39 divided by 52, close, then open another pair, then 38 of 51, then open 37 over 50, and 36 of 49. And I'm getting 0.6962. Just out of curiosity, let me put myself on float, see if I get the whole decimal. See what the whole, because the whole decimal is going to cause me to round again, but let me, that's what the full decimal looks like. 0.69618.
I got it.
Yeah.
I accidentally divided by 51 on
Oh, that's
twice.
fine. But if that way makes, if this way makes sense to you, when we get to, like I said, a couple more sections, we'll be able to use another concept called permutations to help us with this. All right, let's go on to number 15. So here, let's see. Okay, homework. This one. Okay, number 15 says, it was reported that 19.8% of computer games sold in 2005 were classified as family and children. Choose 5 purchased computer games at random and find the probability that. Okay, so again, either they were classified as family and children or they weren't. So here, you go ahead and use the complement. So I'm going to say that first we want to say none of the 5 were family and children. So here we have, this is problem 15 part A. So this is, oh, and this is equal to point. Oh, wait a minute. Let me go this out of the way. Okay. So then this 15, we have 19.8% were family and children related, right? Family and children classified. Now, if 19.8% were family and children, then I'm going to write, and I'm going to turn this into a decimal. I'm going to say 0.198. Okay. I'm going to move this out. And so this is going to be, let me go to my other screen here. I'm going to say that this is 1 minus. So I'm going to clear this. This is 1 minus 0.198. And this is 0.802. So now this percentage is the percentage that is not family and children. So here we have, this is equal to 0.802, right? And these are, and if I want, I can put a 0 back here. These were not family and children related. Okay, so we want to choose, it says that we're choosing 5 of these. Choose 5 and find the probability that none of them were family and children. So here you want probability we're gonna say for part A, we're gonna say choose 5 and find the probability that all 5 were not family and children. So that just means that we're going to have our percentage, 0.802, raised to the 5th power. Because we already calculated that percentage and we're choosing 5 of those independently. So we're just going to multiply that all together. So here, this is going to give us zero point 802, and we're going to raise it to the 5th. So we have, and if I put this back on 4 mode, 4 decimal places, right? Then I'm going to get 0.3318 as my answer there. Because the 9 behind the 7 makes the 7 and 8. Okay. Questions about part A?
I got 0.332.
Okay, if you round it to 3 decimals, you're going to get 332. If you round it to 4, you're going to get 0.3318.
Well,
So-
wouldn't she deduct points if I put that answer instead of this?
It depends on how many decimal places she wants. If she asks for 3 and you give her not that number, she will. But she doesn't specify on the homework how many she wants. She usually uses 3 or 4 decimal places. So be aware of that when she will specify. But let me see what she has on the answer key. This one she has, hold on. I'm not on the correct screen. Let me figure out where I'm at. There we go. We are this one. Okay. She has, for that one, yeah, here she went to 3. Now that's interesting because everything else she has 4, but here she used 3 decimal places. So, but to 3 decimal places, it's 0.332. To 4 decimal places, it's 3318. So you're okay, either answer, but if you want to go to 3, it's 0.332. Okay. But that's the only one of the ones that she did where she only used 3. The exception being part B on number 11, and I'm wondering if that's because it came out as but no, if she didn't specify, then she'll take 3 or 4 decimals, but she's pretty good about specifying how many she wants. All right, let's do part B. Part B says, okay, part B, what does part B say? Part B says find the probability, whoops, nope, not that one. We want to be, where is it? Okay, hold on, I have to find the homework again. because I closed it to put it over there. Okay. All right, let me go up here. We're looking for the probability that at least one of the 5 was family and children's. So let me show you that. This is there it is. At least one of the 5 was family and children. So here, what we're going to have is we're going to have 1 minus the probability of no family and children, which relates really nicely to part A because you already have that. So here, remember this answer was, let me put it up on the screen. We had, this was 0.332, right?
Yes.
And here we have, if we're doing at least one of the 5, then we know that the probability of at least one family and children was, or is, I should say, because it's a complement of that event, is equal to 1 minus probability of no family and children, right? Well, as I said, we already calculated that in part A. So here we're going to have 1 minus 0.332 because I already have that answer. If you want to write the actual calculation, it's 0. How we got that was 802 to the 5th. And so this answer
is 0.668.
Yeah, it's just a complement, or you can substitute this in if you want. Some people, and that's acceptable as well. You can substitute this answer into, so your answer from part A, if you want, into that, and you're going to get 0.668, which is 66.8%. Yeah.
Mhm.
Okay.
Yep. Next up, I have a question on 4.4.
Okay. How far did you get?
5 and 6.
Okay. Okay.
I did everything except for 5 and 6.
Oh, very nice. Very good. You've been busy, huh? All right, let's take a look at it. And I had that up earlier this morning, so let me see if it's still there. Because I was looking at it too. I figured that somebody would be in to ask about it. Let's take a look. Okay. I've got like way too many screens open. But it doesn't look like, okay. Maybe I closed it, or maybe it's down here. Nope, it's down here. 4 point, which one are you? Nope. Okay, it's in my downloads. Let me open my downloads folder and I will show you that. 5 and 6, huh? Okay, let's take a look. All right, so let me share the screen here and see what's up. So we've got is this the one you wanted to see?
Yeah.
A knitted, okay, so number 5, right?
Mm-hmm.
A knitted hat pattern comes in 4 styles with 4 stitch options and 3 sizes. And there are 7 yarns appropriate for the hat. Okay, so, but then she has this little caveat in there that because there's a little trick to this. There's 4 styles, 4 stitch options, 3 sizes, and 7 yarns. Okay. Disregarding size, that means we're not going to worry about this category. So we're not going to include that. Disregarding size. How many different hats can be made? So we're going to look at what we call the fundamental counting rule, right? So we have 4 ways to do the style. We have 4 stitch options. And we have 7 yarns. So if you multiply that out, let's do that. We have 4 times 4 times 7. That's going to be 16 times 7. And I think, let me check it here. Let's see. New share. Do I have the calculator? No, because I'm not in the right window for that. Let me stop
Wait,
sharing.
why'd you cross out the 3?
Because it says disregarding size. Okay.
Oh.
Disregarding size, so we're not counting that part. Normally we would, but she said disregarding size, how many are possible? So in this case, we have, let me open it. Okay, so now we have that. We've got 4. Okay. 4 times 4. Oh, I'm gonna have to select the mouse on the screen, I think. Yeah. 4 times 4 times 7. And that gives us 112. Okay. These answers should be whole numbers, by the way, because in this section, we're counting the number of ways to do something. So you shouldn't have a decimal answer for that.
Wait, hold on. What?
In this section, 4.4, we're counting the number of ways that something can be done, right?
Yes.
And so when you're doing these problems, all of these answers should be whole numbers. Okay. There shouldn't be decimals in these answers because we're looking at how many ways we can do something. Okay.
All right.
Okay, so that was the trick with number 5. Now number 6, what's the trick with number 6? Let's see. it says, given the characters A, B, C, H, I, T, U, V, 1, 2, 3, and 4, how many 7-letter passwords can be made? Okay, so this is the first question. We have 7 character passwords, 7 characters. So that means we can use anything on here. And here she says, no repeats are allowed. So we have to count the number of characters in this list. There's 1, 2, 3, 4, 5, 6, 7, 8, plus 4 numbers. That's 12 characters altogether. Okay, so there's 12 characters on this list. And we're making a 7-character password. Okay, so and we can't repeat anything. So one of the ways to think about this is to think about having 7 slots to do something in. And for the sake of our purposes, the different orders of the characters would make a different password, obviously. So order matters here. So we're going to have, one way to write this would be, we could do, you're going to have 7 slots, and you could say that one way to think of this would be to say, we have 12 in the first, you have 12 options for the first one, then 11, then 10, then 9, right? Then 8, then 7, and then 6. That's one way to think about this option. The other one would be to use the permutation notation. So you could do this part and have a 7-character password. 12, 11, 10, 9, 8, 7, 6. Or you could write this as, 12, and we could say permute it, which means choose it in order. We could say 12, and then we could say permute.
Or 6.
Well, we're
Oh, 7.
choosing 7 characters, so that would be 12p7. You could also write it this way. But this would be your, either this way, some people write it out, or you could write that, or you could write this and then write that, however you want to do it. But that's if you don't repeat. Now, here it says how many, if you must use all 4 numbers in the first 4 characters of the password. Okay, so this is a little different. This is set up just a bit differently. So here we have 7 slots. We have to use 4 numbers as the first 4 characters. That means that in our first 4 slots, we have 4 options for the first character, right? Because we have one of the numbers, right? And I'm assuming we're not repeating anything because she said that. Times 3 here, 2 here, and 1 here. But now we still have 3 more characters in the password here. So you have to think about the letters. There are 8 letters. So we have to think about, I have 8 characters for the first part of the alphanumeric part of the password, times 7 times 6 because I'm doing times 6 because I'm doing I'm doing the last 3. So I have to use all 4 numbers as the first 4 characters, and then I have alphanumeric characters after that. So this is going to be, let's see, what is that? 12, 24 times. Okay, so let me do a little bit of math here on the calculator. Let me write this down. 12 permute 7. And then this is going to be 4 times 3, 2 times 1, and 8 times 7 times 6. So we end up with, come back to the screen here. So the first case, do you know how to get the permutation on your calculator already?
Yeah, I just go to math and then go to probe.
Right. Probability or
Probability.
Yeah,
And
good.
it's number 2.
Yeah, so
But
very
what do I
good.
put again?
So, okay, hold on. Let me put this on the screen. I need my mouse. And this is not my mouse. Wait a second. Okay, all right. So we're gonna do 12. Math. Probability. I'm gonna use the arrow key there. And I'm gonna use number 2 for permutation. Yeah, so what some students do is they put the permutation in first. You have to put the first number in before you hit that. So be aware of that. And that's quite a large number there. That's 3,991,680. I'm going to put this back on float just so it looks a little bit
And for
cleaner.
B?
For part B, okay. So for part B, remember we have the numeric characters first. So we have, there's a couple of ways to write it. You can write out all the numbers like I did, or you can use 4 factorial for the first part, the 4 times 3 times 2 times 1, right?
Is that the exclamation mark?
That's the exclamation, right? Math, then probability. Now, that's the first 4 characters, right? But we have to multiply that. That's our numbers. We have to multiply that by the fact that we have 8 characters in the next position, 7 in the next after that, and 6 in the last position, right? Because we have a 7-character password. So we get 8,064 for that.
Then why does the answer key say 680?
Let me see. Maybe I did something wrong. Unless she's, let me take a look, because I didn't use
Because that one is technically for C.
repeats. Oh, is there a C? Let me check.
Yeah, 8064 is C.
Okay, but there's only 2 parts of the question to number 6. Given the characters, how many 7-character passwords can be made? No repeats are allowed. How many if you must use all 4 numbers as the first?
Oh, I see
Okay.
it now.
Yeah, either that does she have a 3-part answer to this? Because I'll have to ask her if that's the case.
No, I was just looking wrong.
Oh, no. Yeah, okay. No worries. No worries. We're okay. All right. Anything else?
Hold on 1 second. Yes, number 22.
22. All right. Let's see. Oh, this is one of her favorite problems. Expect a variation of this on the quiz. she likes to give variations of this problem. There are 7 women and 5 men in a department. How many ways can, okay, so this has multiple options. 7 women, 5 men in a department. I'm going to write this down and then put it on the whiteboard. 5 men in a department. How many ways can a committee of 4 on a committee be selected? How many ways can this committee be selected if there must be 2 men and 2 women? How many ways can this committee be selected if there must be at least 2 women? At least 2 women. So here, okay, yeah, this gets to be, this is not as hard as it looks, but it's probably one of the harder ones on here, but let's see what we've got. So here, the first part is not all that bad. The first part's pretty straightforward. So it says we've got, this is 4.4, number 22. All right. So we've got 7 women and 5, let me write it out. 7 women and 5 men in a department. Okay. And the first question says, A says, how many ways can a committee of 4 be selected? Well, you have to think about how many total people you have. You have 12, 7 plus 5, right? So there are 12 total people, right? And in this case, there aren't any restrictions. Now, if you're on a committee, this is the other thing, because you'll see this in some of the other problems. Sometimes the committees have positions, president, vice president, treasurer. If you have that, then the order matters, because like me being the president would be different from you being the president, right? But if you don't have positions, then order doesn't matter here. So order is not important because there are no positions for the members. It's just a committee. So that leads us to a combination idea rather than a permutation in this case. So here we have, for A, we're just going to say that it's 12 from those 12 people. We're going to use a combination and we want to choose 4 people. So 12, choose 4 people. And that would be our answer. So let's see what that is. Let's go to calculator. And we have 12, math, permutation, and CR 4. Enter. 495 people, or 495 ways, I should say. 495 ways to choose that committee. Okay. So this is $495 ways for the first one. Now the second question, put the second question over here. The second question says, how many ways can I do it if I need, how many ways are possible if there must be 2 men and 2 women on the committee. So, okay, now the thing about this is we have a couple of groups. We have men, we have women. One of the things I always tell students, because I see them do this a lot, you have to choose men from among the men and women from among the women. So we're choosing 2 men and 2 women. So we have from the set, so we're going to have 2 groups here. We're going to have from the 7 women, I'm going to write, this is either, I'm sorry, not yet. I'm going to write this, but later.
It's
First
7C2.
Right, for the first part. But what she wants you to write before that, let me put, you're right that it's 7C2, but then it's also, you have to choose from the men also, right? So 5 choose 2. So 7C2 times 5 choose 2, but let me show you why that is. When you write this out, she wants you to write this. She wants you to say that I'm doing probability, or not probability, but the number of ways to choose 2 men and 2 women, right? So you're gonna have from the 7 men, from the 5 men, 5 choose 2. You can do this in either order. 5 choose 2 and times, right? 7 choose 2. And here means that we're multiplying, or would mean we were adding. We're going to get to that in a minute. So 5 choose 2 times 7 choose 2, and you get, I think that's what, 210,
10.
I want to say.
And I just basically added up what 5C2 equals and what 7C2
Yeah.
equals.
That's fine. Yeah. And you can either, some people write it individually underneath. You don't have to do that. You can put the whole thing in your
Yeah,
calculator.
because I tried that on a calculator and it probably didn't turn out well.
Okay. However, yeah, however you feel comfortable doing it. And I think this one does have a C, right? Let me check that. I think this one does have another part. How many ways, yeah, how many ways can this committee be selected? If there must be at least 2 women on the, now this is not going to be able to use the complement because we have at least 2. So we're going to have to work with several groups of fractions. Must be at least 2 women. Remember, there are 4 people. So here we're going to say, we're going to have to do a little bit more work. Let me put some C on a different whiteboard here. So this is part C of that same question. We want how many ways can the committee be selected if there must be at least 2 women, right? So here, there's 3 options here. There's 2 women and 2 men, which we already calculated. Okay, we calculated that. Or 3 women and 1 man, or 4 women and no men. 0 men. Okay, so we already calculated part of this. But if you want to write, then this is going to be from the 5 women, from the 5 men, 5 choose, sorry, this is women. So 7, I'm going to write it in the same order that I wrote it. 7 choose 2, and means times, so times. 5 choose 2. We have that already. Now, or means plus, so I'm going to add plus. So this is plus. And here I have to choose from the women. So here I have 7, choose 3, times 5, choose 1, right? So 5, choose 1, or plus 4 women. So that's 7, choose 4, time 5, choose 0. And 5, choose 0 is just going to be 1. So this is times 7, choose 4, times 5, choose 9. Okay. So you can work it out. And if I grab this 7, choose 2, 5, choose 2, 7, choose 3, 5, choose 1, 7, choose 4, and 5, choose 0. So here, let's go and let's do some calculations on the calculator. So we have 7, choose 2 is 7, math, probability 2, and check. Oops, forgot my 2. 7, choose 2, there it is, 42. And 5, math, probability 2. This is 20, okay. 7, choose 2, 5, choose 2, or, so then you have 7, choose 3, 7, math, probability 3. Sure. And 7, choose, oh, sorry, not 7, it's 5, excuse me. Let me go back to that. This is gonna be 5, choose 1. So we have, whoops, 5, math, probability 3, 1. And that's 5, which we probably could have figured that out. And then 7, choose 4. Going to be 35 again. And 5, choose 0, as I indicated before. But let me just show you here. 5, choose 0 is just 1. So that term doesn't add anything to your product. It's just 35 times 1 for that. This is 7 choose 3 is 35 again. And 7 choose 2 and 5 choose 2 is and I accidentally I just realized I put permutation in here by mistake, so let me fix that. 7. Let me fix this result. This is supposed to be combination, not permutation. 7
21.
choose, yeah, it should be 21, and 5 choose 2 should be 10. Is that right? I'm doing it from memory, so let me do it, make sure I'm not math, probability, and CR. So now, yeah, now we should match. This is equal to 10. So now we have this. We have all of those, so we can put it in. And you've probably already done it. So this was 21 times 10
Equals 210.
This was 210 down here. And then 7, so we're adding, right? We have to find another product. We have to add. 7 choose 3 was 35, right? So
Yep.
35 times 5. And that was what, 200
420. Oh, 35 times 5 is 175.
175. Yeah, okay. All right, so this is 175. And then this one we already had done before. 7 choose 4 was 35 times 1, right? So this is another 35. And if you add it all up, you get, what is that, 285, and then
420.
3, yeah. So that's 420 ways to get at least 2 women, okay? Expect a problem similar to this on your quiz and probably on the exam. She likes variations of this problem. So
All right.
there's also one in the PowerPoint like this. The last PowerPoint slide has an example like that in there. So good job.
Yeah, and that's all I had.
All right, Jason, good deal. I'm glad that these last 2 sections were a little bit kinder to you.
Mm-hmm.
All right, well, you take care and we'll see you again. Okay.
All right.
All righty, bye.
Goodbye.